Hello everyone, and this is the fifth video of our series on UPSC Civil Service Mains PYQ. And today my voice will be somewhat low, so cope up with it. And this is from Radiation Heat Transfer Numerical of 2021. So, and it is a 20 marks question, a very good question. You can score easily. Uh, Here, the question is determine steady state. So, first underline the word steady state temperature of two radiation shield placed in the evacuated space between two infinite plates at temperature 555 Kelvin and 278 Kelvin. Here two infinite plate and two flat radiation shields are there. So whatever the shape factor or view factor is there between any two surface will be 1, and emissivity of the all surfaces is 0.8. All the surfaces, that means including both the plates as well as shields also, and Stephen Boltzmann constant value is given. So now first of let us draw the diagram. What the question says, this red one is two plates having temperature T1 is equal to 555 Kelvin and T2 that is equal to 278 Kelvin. Okay, and I'm giving the emissivity of this both the plates as a E1 name Y, and these two shield having temperature TA and TB, and these emissivities I'm going to take E2. Why? First of all, because in every case that is not the same, because there may be a chance that in next time they will say the emissivity of this red plates having zero. 0.9 and emissivity of the radiation shield is 0.7, so there will be a different. So we have to first write down the general formula for heat flux, that means heat transfer per unit area. I'm going to write first the generalized equation, and then after I will give the equation where all the emissivities of the surface is same. So generalized equation is sigma into T1 power 4 minus T2 power 4 divided by first here, that is a surface resistance from first plate 1 minus epsilon 1 upon epsilon 1, plus there is no any space resistance and view factor is 1, then 1 plus this surface resistance of plate from this side and having emissivity epsilon 2 divided by epsilon 2 plus surface resistance on this side, again 1 minus epsilon 2 divided by epsilon 2, then again space resistance plus 1 plus this space resistance from this side also 1 minus epsilon 2 divided by epsilon 2, again surface resistance from this side plus 1 minus epsilon 2 divided by epsilon 2 plus 1, there is no any space resistance and shape factor is 1, and finally this side of the surface, this is surface resistance 1 minus epsilon 1 divided by epsilon 1. So when you simplify this, so you will get some terms in epsilon 1 and epsilon 2, but here in our case epsilon 1 is equal to epsilon 2 is equal to 0.8. So whenever emissivity of the all the plates are same including the radiation shield also, so our formula that is sigma into T1 power 4 minus T2 power 4 divided by 2 times epsilon minus 1 plus 2n by E minus n, where n is equal to number of radiation shield, number of radiation shields. So this is the, if there is a no radiation shield, then 2 times epsilon minus 1, that will be formula, and if there is a 1 radiation shield, then that is put n is equal to 1. Here there are 2 radiation shields are there, so we can write steady state equation sigma into T1 power 4 minus T2 power 4. Whenever I'm simplifying, so 6 by epsilon minus 3, and as here please follow this statement steady state. So whatever heat transfer is there, heat flux from this side it will be on other side also, heat flux. Okay, so heat flux will be there. Steady state, whatever the, if you take the steady state heat flux from 1 to 2 plate, or if you take this first plate and first radiation shield, or between two radiation shield, the heat flux will remain same, only the resistance will, the value of resistance and temperature is going to change. So now we have the given the value of 5.67 Stephen Boltzmann constant into 10 power minus 8, T1 power 4, that is 555 power 4 minus 278 power 4 divided by 6 by 0.8 minus 3. So when you solve this, you will get the heat flux as 1120.2 watt per meter square heat flux, 1120.2. So it is a heat flux. Now for between plate 1 and uh, this radiation shield, we can write steady state equation Q is equal to sigma into T1 T1 power 4 minus Ta power 4 divided by 2 times epsilon minus 1. Okay, because emissivity of the both plate is same, so we can consider as a two infinite plate case and put the value of Q over here. Sigma we know, T1 is a 555, epsilon is also known. So when you put this, so you will get Ta, the temperature of the first radiation shield, that is a 505 Kelvin. Okay, 505 Kelvin. You can easily solve this, and similarly apply the steady state equation between two surfaces, that is Ta power 4 minus Tb power 4 divided by 2 times epsilon minus 1. So what is the Ta and Tb? This thing between these two plates, two radiation shield also, we can put the apply this equation as the flow is steady state. So if you put this value Ta over here, Q value over here, and epsilon we know 0.8, so you will get the temperature at on the other surface, that is 433.77 Kelvin. So this is the answer of the question that they have asked. I hope you like the solution, and sorry for this some low voice because of some problems. So just cope up with it, and thank you for watching this video, and like and subscribe this video and subscribe this channel for more videos like this. Thank you.